Okay, this worksheet here is a combination of what we've been doing the last 2 or 3 days. So there's 2 or 3 days worth of homework here. Stretches back from last Friday till yesterday. If we take a look at problem number 7, you have a perpendicular bisector to the segment of 7, -1, and 1, 3. So in problem number 7, we want a perpendicular bisector to a segment with endpoints of 7, -1, and 1, 3. Okay, and what we discussed yesterday is when you're talking about a perpendicular bisector, you intersect it at its midpoint. So the first thing that we need to determine is we need to determine the midpoint. So if you've not done it, do it. What is the midpoint of these 2 points? What is your midpoint? And this stretches you back to, okay, how do we deal with the midpoint? How do I determine what a midpoint is? Preston, what do you get your midpoint to be? 4 and 1. How'd you get 4 and 1?
7 plus 1 divided by 2 is 4. I don't know how I got that. That's like
Well, you can take -1 plus 3 and divide it by 2 also. You're taking the average of your 2 x values, your average of your 2 y values. So you have the midpoint. Now we have to be perpendicular to the segment. And what we talked about yesterday when we talked about perpendicular segments, perpendicular lines or perpendicular segments have opposite reciprocals, okay, with respect to their slopes. So what we must first determine here is taking a look at these points. Let's calculate our slope, delta y over delta x. And once again, if you have not done it, please do it. Find your slope. Olivia, what did you get for your slope? -2/3. How'd you get that?
I did y2 minus y1 over x2 minus x1.
So we have -3 minus the -1, y2 minus y1 over 1 minus 7. So we have 4 over -6. And what did you say the slope was? -2/3. So if we come over here and look at the slope perpendicular, what is our slope perpendicular going to be, Kirsten? 3 over 2. Because our perpendicular slopes are going to be opposite and reciprocals. So now we have a slope, which is 3/2, and we have a point that we have to go through. And our final is we have to find our equation. So plug in your slope. Once again, if you have not done it, please do it. Plug in your slope of 2/3. Plug in your ordered pair, 4, 1. Yeah.
Can I take the picture?
Whenever you have to get the picture, just get up and go. All right? Don't have to worry about asking, just go. So we have 2/3, or 3/2, x minus 4, then get into a form that we can deal with. Multiply both sides by your value of 2, and then get into form ax plus by is equal to c, or if you go y equals mx plus b, that is fine also. I typically go ax plus by is equal to c because I don't like to include the fractions here. Noah, what do you get for an equation?
3x minus 2y equals 10.
Equals what?
10.
3x minus 2y equals 10. Alright, take a look at one other problem. Problem number 12. Problem number 12. We have the equation of we want to determine the equation of a circle with endpoints of the diameter at 1, -3, and 7, 5. So 7, 5, and 1, -3. These are the endpoints of the diameter. So our circle will be this. Not bad.
That's pretty good.
Not bad. I got one there. Feel pretty good about myself right now. Doesn't look like too much like an egg. So this is a diameter. Okay? We are looking for an equation of a circle. We have center in HK and radius R. We have a base equation of x minus h squared plus y minus k squared is equal to r squared. So we need to find the center point and we need to find the length of the radius. Problem is I have the endpoints of the diameter. I don't know what the length of the radius is, but I know the endpoints of the diameter. Well, what can we do to maybe find our center point here? Where would the center point lie in regards to that diameter? The midpoint. If I take a look at the midpoint here, my center is going to be the midpoint of these 2 points right here. So he's going to be my center, it's going to be the midpoint. So what we must determine to find the center point, this is our midpoint. So go ahead and determine what your midpoint is. Make what's your midpoint?
4, 1.
4, 1, which is also going to be our center point. So what we now have is we have a starting equation, x minus 4 squared plus y minus 1 squared is equal to my radius squared. So I now need to find the length of my radius, and the length of my radius is this value here. So that point is 4, 1, and I have two endpoints. This is 7, 5, and 1, -3. So to find my radius, that's the length from my center to one of the points on the circle. So I need to find that distance from the center point to the point on the circle. Or if I wanted to, this equation defines all the points on the circle. This equation defines every one of these points on this circle. I could pick one of these points and sub it in. I could sub in my 7 here, and I could sub in my 5 here. And that would give me my radius squared. So I have 3 squared plus 4 squared is equal to my radius squared. So I have 9 plus 16, 25. So my radius squared is 25. Now, I really don't need to know my radius. All I need to know is my radius squared, because that's in my equation. So my equation will be x minus 4 squared plus y minus 1 squared is equal to the value of 25. Common mistake on this one is people will tend to find the length of the diameter, find the distance between those 2 points, and put that in for r squared. That is a common mistake. Any other questions you have on any of the problems on this worksheet?
Either 8 or 9.
8 or 9? Does it matter which one? Okay, let's take a look at number 9. Determine if you have any symmetry. Well, symmetry is defined to us as when you have an odd function, we have symmetry about the origin. When you have an even function, you have symmetry about the y-axis. And if you're even with respect to y, with the y variable, which means all your exponents are even up here, you're going to be symmetric about the x-axis. How we determine odd or even? Once again, as we talked about before. If you sub in x equals 2, x equals -2. And then evaluate what happens with your y value. So in number 9, we have y equals x to the 4th plus 7x squared minus 19. Now what I tend to do with this, when I have to sub in values into a function, if I have my calculator sitting there, I'm going to use my calculator anyways, why don't I use it to make sure I don't make a mistake? In your y, clear all your values out. Type in your function. X to the 4th plus 7x squared minus 19. I get lazy. I don't want to find my caret and then put a 4 there, and then I have to sometimes remember to pull the 4 back out, or the caret out of the exponent, because typically I do not remember to do that, and then I have this nice long exponent. So I just hit the x 4 times. Okay, and I'm gonna calculate a value. Make sure my window's good, my window's good. I'm gonna calculate a value. So I go second and calculate up here, which is above your trace, and I'm gonna do a value. Gives you a graph. Type in 2, and then type in -2. And then you don't have to worry about, did I put in parentheses around my negatives? I'm gonna have to type in the values into my calculator anyways. Why not just type my function in and do my value that way? A lot easier. Okay, it's a little KYC. Know your calculator. The one thing that I've learned with that calculator, and this is the thing I use a lot, because you've subbed in enough values into equations. You subbed in and solved for other values. Okay, why do I have to continue to do that? I already know how to do that. Well, let's use the technology we have with our calculator and make life easier on ourselves. So both of my values come down to 25. So x equals 2, y equals 25, x equals -2, y equals 25. These are equal values. So you're even. Opposite gives you equal, you're even. Opposite gives you opposites, you're odd. Once again, that's opposites give you opposites, you're odd. Opposites give you equal, you're even. Or you can think about all my exponents are even numbers. If all my exponents are even numbers with respect to x, I'm going to have an even function. Now the one that's symmetric about the y is not going to be a function, but if you have all your exponents of your y are even, then you'll get an even function. That's why in number 8, if you solve for y, you have y squared is equal to 2y squared is equal to, or plus, or you can put in values for 2 for x and 2 for, or -2 for x and +2 for x. Or you can think about, I subbed in 2 and -2 and you don't get values, but if you have all even exponents of y, then you'll be symmetric about the x-axis. Or if you sub in opposite values for y, you're going to get the same value for x. So like when you sub in opposite values of x, you get the same values for y. You put opposite values in for y, you get the same values for x. Any other questions? Once again, KYC, know your calculator. It's a nice tool to have. Yep.
On number 8, when we also subbed in 2 for y, does it matter if we do like positive, -2, or like why does it need 2?
You should put in positive, negative values for y that aren't 1. Okay, you can pick any other value you want. I picked 2 because 2 is even easy to deal with. That's why I put it. It has to be one positive, one negative, yes.
Oh, okay.
You have to have opposite values for the x or opposite values of y will give you equal values for x. Any other question? All right, we have 2 things today. We have an in-class assignment. And when you're done with that, I have a worksheet up here for you that will sort of review everything that we've done. Sort of like a review for the review. done, you can turn this in and pick up a worksheet.